Hello, welcome to the video notes for lesson 9-4. This begins on page 27 in your notes packet, and this lesson is all about rotations. So let's take a look at the lesson targets. I can identify a rotation, and I can rotate a figure to its image. So, rotations are essentially turns, and we are going to look at the different turns in this lesson and try to understand what we need to expect when we do a rotation. So remember, a rotation is a turn or a spin. And I might want to, well actually I'll talk about the different turns in just a little bit. Alright, so let's take a look at the example here on page 27. And I realize the numbering is a little off. Essentially this keeps extending the previous lessons, and that's why it's starting at number 13. Not really important. Let's follow the directions, however. So the first direction is to plot the point 2, 5 and label it A. So the point 2, 5 is here, and I'm going to label that A. Now we're going to rotate point A 90 degrees counterclockwise and label it B. Alright, so I want you to understand what that means. If you take your paper and if you turn it 90 degrees, what did we say, counterclockwise? It's going to look like this. Now, where is A? It's actually, I know we plotted it at 2, 5, but if you look at it, it looks like it's at 5, 2. Okay, so let's rotate this back because we don't want to keep it there. So that's the strategy you're going to use if you can't see it, is to actually turn your paper so that you can see it the right way. So we just said this is going to be at negative 5, 2. So this is going to be point B. Alright, so we did A. Let's label point, or let's write down what we ended up with, negative 5, 2. And it's interesting if you look at the numbers that we started with, 2, 5, and what we have for point B. If we rotate 180 degrees, so think about starting here and turn your paper all the way upside down, and you end up down here at negative 2, negative 5. So turn your paper upside down and you'll see what I'm talking about. And that's point C. And then if we take from point A and we go 270 degrees, we end up here. That's our point D. And that is the point 5, negative 2. And then if we do 180 degrees, rotate point D 180 degrees, we end up here, all the way back at B, and that's our, oops, not B, this is E, and the last task tells us to name point E, and point E is negative 5, 2. Alright, so that's what a rotation looks like. Yes, you may actually physically turn your paper to try to solve this. It's okay. It's a strategy. It helps and it works for some people. Okay, let's go ahead and take a look at page 28, the next page. And we're going to talk about what you need to know about rotations. A rotation, a turn, is a rigid motion that turns a figure about a fixed point called the center of rotation. Oh, by the way, on the previous page, and maybe you should turn back to this, the point of the center of rotation was the origin. And that's what we'll be focusing on, is the origin as the center of rotation for most of our rotations or turns. However, it is possible to have a different center of rotation somewhere else. And you'll learn about that when you get to the geometry course in a couple of years. Okay, so back to what we were talking about. So the center of rotation is the point that we are rotating around or about. The angle of rotation is the number of degrees the figure rotates. A positive angle rotation turns the figure counterclockwise. So I want to talk about the rotations, the number of degrees. We'll be focusing mostly on 90 degrees, 180 degrees, 270 degrees, and 360 degrees. There are obviously different rotations than these four, but these are the main four that you will see. And also I want to point out a positive angle rotation is counterclockwise, so that means a negative rotation of rotation is going to be clockwise. Alright, so let's take a look at some of the turns down below. 3 of the 4 typical turns that I talked about. So rotation of 90 degrees, basically this is one turn. Turn your paper one time. So turn it sideways, if you will. Rotation of 180 degrees is 2 turns, or turn it upside down. And then 270 degrees is 3 turns. And, oh, by the way, on your paper you might have a hard time seeing this triangle, so you might want to outline it if you can. 270 degrees is obviously 3 turns. And then 360, you don't really need to turn it at all because that's 4 turns, which means you end up basically back where you started. Alright, so then we've got this right here, an example, a triangle A prime, B prime, C prime is the image of ABC after a 270 degree rotation about the origin. You can use arrow notation to show each vertex. We've already seen this, so I'm not going to go over it again, but there's an example for you. Same thing, only it's a rotation instead of a reflection or a translation. Alright, let's go back up to the top, and usually on this page, so we need to just put down some details here. Put a star at the top of this page, and remember, the image is going to be congruent. There's our fancy symbol. And the orientation is the same. So with rotations, the trick is finding where the image is going to be. Essentially, they change the location. So everything else remains the same, unlike with a reflection where the orientation is the opposite. The orientation stays the same. Alright, so let's take a look at another example over on page 29. So here are the steps. Label the vertices of the image, or write them out. Follow the number of sequences of the quadrants. Turn the paper for each 90 degrees that's needed for the rotation. So remember, 1 turn, 2 turn, or 3 turns. And then graph the point, label the vertices of your image. Alright, so I'm going to show you how to do this in this example, and then let you try it on your own in the example below. So we have the point M-A-T-H. So I want you to write down our original points, M, A, T, and H. M is located at 2, 8. A is located at 2, 2. T is located at 5, 2. And H is located at 5, 8. Now, we are going to use some arrow notation, and we're going to do our image, M prime, A prime, T prime, H prime. Now, let me clear the screen and rotate the page for you, 90 degrees. We're going to go counterclockwise. And now, you've got to ignore that we now have the X going up and down. And you got to figure out, where are my points now? Well, M is at negative 8, 2. A is at negative 2, 2. T is at negative 2, 5. And H is at negative 8, 5. Alright, so let me rotate it back. And hopefully you wrote that down. I'm going to write it down. So, M is at negative 8, 2. Now, if you look at the original point, I think you can see a relationship here. Negative 5, or negative 2, 5, and then negative 8, 5. And then you plot your points. So, negative 8, 2, negative 2, 2, negative 2, 5, and negative 8, 5. And then you label, connect them, and make sure you label them, because that is the key to this. M prime, A prime, T prime, H prime. So here's the image after a 90-degree rotation. And we can see, using arrow notation, where the points came from. Alright, I'm going to ask you to do something a little difficult. Well, sort of. This is an easy rotation. It's 180 degrees, so basically turn your paper upside down. You have, let's do RAP. So, at the very least, write down the coordinates of these 3 points. If you think you've got it, I want you to try doing the rotation and come up with the points for R prime, A prime, and P prime on your own and graph them. Alright? And we'll see how many of you can figure this out. Alright, that's it for this video lesson. Good luck, and we'll see you in math.